Welcome to this explainer. Today, we're uncovering how a completely community-driven mapping tool basically flipped a multi-billion-dollar premium tech industry right on its head. We're talking about QGIS, a piece of software that transformed Geographic Information Systems, or GIS, from this highly exclusive, crazy expensive walled garden into an accessible sandbox for literally anyone with a computer and a dataset.
Let's kick things off with a pretty mind-boggling number, 15 million. That is the estimated number of monthly active users quietly powering their spatial analysis with QGIS right now. We're talking about everyone from urban planners and environmental scientists to data journalists and weekend hobbyists. A massive global community relies on this tool every single month to, just make sense of the world around them. And to put that global scale into perspective, that translates to about 700,000 privacy-safe server pings registered every single day. See, when you open the software, it sends a single, anonymized ping to a central server. But what's really wild here is that this is actually a massive undercount. If a giant corporation or a university has, say, 50 users operating behind a single IP address, well, it only registers as one single user. So the true daily scale, it's likely much, much larger.
All right, moving to section 1, the underdog's timeline. So, this didn't just magically start out with millions of users and endless features. It actually began with a super specific, really simple problem that needed solving back in 2002. Gary Sherman created a basic viewer for post-GIS databases because at the time, people had these databases storing spatial data, but absolutely no easy way to visually look at it. Originally called Quantum GIS, it hit version 1.0 in 2008. Now, it boasts mature, highly stable long-term releases backed by a registered nonprofit and a huge developer network. Talk about a glow-up, right?
Now, if we compare this to the alternatives, it's like night and day. Premium GIS platforms usually come with incredibly expensive licensing fees, closed proprietary code that you can't even inspect, and strict operating system restrictions. QGIS, on the other hand, operates under an open-source license. It is 100% free, the code is totally transparent, and it works seamlessly whether you're Team Mac, Windows, or Linux. And this tool is so ridiculously powerful and cost-effective that even the absolute biggest tech giants had to take notice. Listen to this. When spatial data expert Ujjwal Gandhi was building mapping teams at Google, they realized they had hundreds, and eventually thousands, of internal GIS users. Ironically, maintaining those premium commercial licenses at that sheer scale was completely unsustainable, even for Google. So they actually migrated their internal teams over to QGIS, which is just a huge testament to its enterprise-level stability.
Let's dive into section 2, real-world spatial analysis. Okay, enough history. Let's look at some actual hands-on spatial magic. We're going to explore 3 totally different scenarios to show exactly how data goes from a messy spreadsheet to a beautiful analytical map. First up, imagine you have raw text data of every major earthquake from the year 2000 to 2020. How do you turn that into a compelling visual story? Because to the naked eye, a plain text file from a government agency filled with thousands of rows of dates and coordinates is just an intimidating wall of text. Well, it's actually incredibly straightforward. You just import that tab-separated database and literally tell QGIS, hey, longitude is my X coordinate and latitude is my Y. Boom. Instantly, those 1,200 boring text rows are projected onto a world map. From there, you just filter out the smaller tremors to show only magnitudes greater than 7 and style the proportional circles based on intensity. In just a few clicks, you've transformed a spreadsheet into a heat map of active geological fault lines. All right, let's bring it a bit closer to home with something a little more quirky. How in the world do you track the squirrels of Central Park? Seriously, this is real data. Volunteers actually tracked the exact location and the primary fur color of squirrels all across the park. So you pull in this GeoJSON squirrel data from NYC Open Data and categorize the points by primary fur color, cinnamon, gray, or black. But here's where it gets really cool. If we load in polygon shapes representing children's play areas, we can draw a 200-meter buffer zone around each playground. Then we run a quick spatial analysis to count exactly how many squirrels were spotted near those specific areas. This right here is the true power of spatial analysis, finding hidden relationships between completely different sets of geographic data.
Okay, but what if we need to navigate a real-world street grid? Mapping, points, and drawing buffers is great, but the real world involves networks and restrictions. So how do you find the absolute fastest bike path through a complex city?
It's all about network analysis. You load in your vector line data for the NYC bike routes, map out your start and end points, and then just let QGIS run the shortest path algorithm. The software evaluates the geometry of all those lines and automatically generates a brand new layer showing the safest, most efficient route for a cyclist. It's almost like building your own custom Google Maps. Which brings us to Section 3, the plugin ecosystem. Now, the core software is fantastic and super lean out of the box, but what really gives QGIS its ultimate superpower is the community. Because it's open source, thousands of developers have contributed custom plugins. You've got quick map services to instantly drop in high-quality satellite or OpenStreetMap base layers underneath your project. Quick OSM lets you download live spatial data straight into your canvas. And if you have messy data, like tree diameters accidentally recorded as text, built-in tools like refactor fields let you instantly clean and convert those into decimals. You literally just install exactly what you need. Because of this massive ecosystem, QGIS has evolved way past just being a desktop application. It's a full end-to-end suite now. Field workers can collect data offline in a remote forest using mobile apps like QField or Mergent Maps, which seamlessly syncs right back to your QGIS desktop. You author the maps there, and then, with QGIS Server, publish them globally to the web. It is the whole shebang. Plus, the software is just ridiculously versatile. It'll eagerly accept pretty much any file format you throw at it. It seamlessly overlays old-school shapefile, which are notoriously clunky, with modern lightweight geopackages and GeoJSONs. And as we saw with our earthquake example, it's completely happy parsing plain text tabular data like CSVs, as long as you've got a latitude and longitude in there somewhere. So what does this all mean for you? Well, you've got 15 million copilots worldwide, absolutely zero licensing costs, and an ecosystem that scales from a phone in the woods to the global web. The barrier to entry is just gone. So the only question left to ask yourself is, what hidden stories are waiting inside your data, and what are you going to map first?